Alright, so I asked you to take the derivative of sine x over cosine x, right?
Total?
Well, what did you get when you got to the very end?
1 plus sine x squared over cosine x squared. We got sine squared.
You're on the right track. What'd you get?
Sine x squared. 1 plus sine squared.
Okay. Okay. Low times derivative of the numerator. Minus
Oh man.
high
Oh no, I didn't do that right. Just kidding.
below all over low squared. So you get cosine squared plus sine squared over cosine squared. What is
Wow.
cosine squared plus sine squared?
1 plus sine squared.
What's 1 over cosine squared? The derivative of tangent is secant squared. Now, I'm not going to... What?
Find out where did you like sine squared over cosine squared?
Because
The 1
cosine squared plus sine squared
equals 1.
is 1. Okay? You will not have to do this every time you want to take the derivative of tangent. You're going to remember it. Much like you remember that the derivative of sine is cosine.
Yes.
Here are the rest of your trig.
See? That's part of the product quotient notes.
Yep. Because we just used the quotient rule to figure out what the derivative of tangent was. Okay? So do you see how the derivative of cotangent is very similar? Right? Okay, but it's negative. The derivative of secant is secant tangent. The derivative of cosecant, negative cosecant for tangent. Okay, so there are some relationships here. There are some patterns. Okay, you need to know these off the top of your head, much like you know the derivatives of sine and cosine off the top of your head. So what we are going to do today, we're going to do some more examples with product and quotient rule, now that we know these. And then we're going to talk about higher order derivatives. And then that's really it. So you should have some time to even start your homework again. Okay? Some of you may need to go back and look at the homework from the weekend. I'm not sure. Or maybe knowing that you don't have to simplify it all the way down, okay, will help you. Maybe you did get to where you actually needed to be. Combine like terms when you can, and then, you know, leaving it as one big fraction is fine.
So are we doing exponentials last day?
Wait, what?
Oh, that's hard.
All right, are we ready?
Yeah.
I just bumped the air now. We're not doing exponentials.
I was like, isn't that like some type of function that we did last year? I didn't even realize it.
Okay. So, if g of x is x minus tangent of x, then the derivative of g, what's the derivative of x?
1 minus
1 minus, what's the derivative of tangent? Everyone together, what's the derivative of tangent?
Secant squared of x.
Yes.
Like if I gave you a piece of paper and I asked for the derivative of x to the n, the derivative of cosine, the derivative of sine, the derivative of tangent, all of the trig functions, you should be able to get a 100% tomorrow. Tomorrow. You need to have these memorized. Okay?
So are you saying that I'm gonna be like,
Probably not tomorrow. All right. How about x times secant of x? Ooh, I just gave it away. What do we have to use? Product rule. Okay, what's the derivative of the first? Times the second plus the first. What's the derivative of the second? So I would want you to rewrite this as secant x plus x secant x tangent. You could take out a secant, and the book might do that. It's really not helpful because you can't use any of the properties that simplify from there.
Is 1 minus secant x one of those special rules? Like, does it equal
Um,
tangent x or tangent squared x or cotangent squared x? I can't remember.
hold on a minute. I'll help you remember. Our trig identities, sine squared plus cosine squared is 1. If we divide everything by sine squared, 1 plus cotangent squared is cosecant squared. If we divide this first one by cosine squared, we get tangent squared plus 1 equals secant squared. So yes, we could rewrite that. Right. Okay, so that brings up a good point. Okay, if you take the derivative in your homework, I would expect 1 minus secant squared, but the book's going to have negative tangent squared because of the trig identity. Okay, so on these odd problems, I really would look at CalcChat to make sure that you're getting the right process and not being super concerned with the simplifying, especially with these trig identities. Okay. All right. Next one. Okay, this is a good one to do and talk about what I would expect as far as simplifying versus, the don't worry about simplifying that I'm telling you. Okay, to a certain extent, we need to simplify a little bit. Okay, so this will be a good example. So, what rule will we be using? The quotient rule. So, low derivative of the numerator would be what? It would be a positive sign of x. Good. Minus high. D low was the derivative of the denominator. All over low squared. Okay? I would not want you to stop here. I would want you to multiply a little bit so you can combine like terms. Okay? So what we have is sine squared minus cosine plus cosine squared. Right? Okay? And I do want you to recognize sine squared plus cosine squared. I think that is an important thing to recognize. What is sine squared plus cosine squared? Okay. It changed a little bit, didn't it? Yeah. And see, that's the kind of the cool thing when you work with trig functions. We have so many identities. I mean, we could keep going on changing this around, right? Trig identities we can do a lot with, but this is going to be fine. And really, on Friday's quiz, this is probably gonna be fine. This sine squared minus cosine plus cosine squared all over sine squared, I would take that, all right? But I do want you to multiply the I below equal to I. I think that would be fine. All right, the next thing we get to talk about is higher order derivatives, okay? We don't have to stop at taking just one derivative.
The derivative.
Yeah. Okay, so first of all, if we have a function y, these are the different notations for the derivative. Y prime, f prime of x, dy dx, ddx of f of x. Okay? The second derivative would look like this, where we have 2 primes. Okay? Or d squared y over dx squared. Okay? This is notating the second derivative. So take the derivative of the derivative. Right, so if your derivative is 4, then the derivative of that is 0.
Is there a third derivative?
If the mean derivative is you want to have the.
Okay, how many are we gonna have to do?
Stop writing it down. It's just gonna keep repeating itself.
Now, I will tell you that the first and second derivative are going to be the most important to us, especially when we get into Unit 3 and what they mean about a function. But we can get going. Now, we can keep going. However, when we get to the fourth derivative, we're not going to put 1, 2, 3, 4 little tick marks. Okay? That's when we can start saying, we can write the number in little parentheses as a superscript. All the way to the nth derivative, Aaron. Okay, now power rule. Is that going to be, if I give you a polynomial to take multiple derivatives of, is it going to be strenuous? No. If I tell you to take the 100th derivative of sine, there's going to be a pattern when you take the derivative of sine over and over and over and over. Okay, things like that. Huh? What? Writing. What do you mean? Never.
No. This is when stuff gets
No, the parentheses
Uh-huh.
important.
Yes, it is. Otherwise, because if there's not a parentheses, then it looks like a power. When there's a parentheses, we know they're talking about the nth derivative. Did you have a question? Okay. All right. We're going to take the fifth derivative. Actually, we're just going to take the fourth. I'm going to change it. Is that okay? Can we take just the fourth? I take the fourth derivative of this. Before we even do it, anybody want to say what the fourth derivative is going to be?
0. Oh, is it because of the power or something?
So, y prime is what? 3x squared minus 10x plus 6. Second derivative.
Okay, you're getting
Third derivative. And fourth derivative. Now, when is taking multiple derivatives going to be a pain? If you have a quotient or the product,
That's
you may have to exercise some patience.
Let's not do that.
Okay. One more type of problem, and then I will get you to your home. Okay? Now, trying to think here. Okay, so I have a table of values for two functions and their derivatives. And I want us to evaluate h prime of 0 if we know that the function h is f over g. Okay, well, I want the derivative of h evaluated at a point. So before we look at the point x equals 0, we should probably figure out the derivative. So h prime of x, ooh, what do we have? We have a quotient. And how do we take the derivative of a quotient? So we have low d high minus high d low all over low, oops, square. Okay. Now, this is our derivative. We want to evaluate it at 0. So what is g of 0? 5. What is f prime of 0? What is f of 0? What is g prime of 0? And what is g of 0 again? So we have 5 squared. So we have negative 15 plus 2 over 25. That seems like kind of a strange problem, right? Okay. On the AP test, they really like tabular data. What is tabular data? Data in a table. Okay. So this is just basically saying, hey, do you know the quotient rule? Yeah, you do. So you can do the problem. Okay. Your homework.
Yes.
Hold on.
Oh. That was a lot.
It's not that much.
Yeah.
It's not that bad.
It just looked like a lot of radish. Oh.
Okay.
Oh.
Yeah. It's a lot of different little chunks.
I don't know. It's already going
I like the hours to keep going back to which problem back to the
Dude, how did you even get
Oh, yeah, you write something. I just keep writing them on.
Use count when needed.
I know that bad, dude.
Did you stop recording yet?
Nope.
Probably that's not. Sorry. We had to have one for the record.